tracking station technicians additional training for the Mercury orbital flight program. The tests and the intra-systems checks are still being conducted to perfect familiarization with countdown procedures and handover control techniques. The delivery of production spacecraft number 14 to the Wallops Island facility initiated the flight test program for this period. During April and May, 3 spectacular flights were produced. The culmination of the entire Project Mercury program is dependent on the results obtained from hardware tested from both perfectly programmed and executed and unplanned malfunctioning flight tests. A maximum dynamic load test of the escape tower sequence at high altitude was planned for April 19, 1961. The modified spacecraft was mated with the Little Joe launch vehicle. During the launch, a hang fire developed in one of the Castor rocket motors. The resultant down pitching of the test vehicle booster produced a much lower trajectory than was planned. The abort took place at 13,000 feet, at Mach 1.47. The main parachute deploy followed and disclosed that no structural damage had been experienced, either in the abort or in the landing. All test objectives are considered to have been met and exceeded. After delivery to the Cape Canaveral launch facility, spacecraft number 8 was unwrapped and underwent rigid systems checks and testing in Hangar S, from which it was moved to the launch site and raised for mating with the Atlas launch vehicle. The payload, a simulated astronaut, was scheduled to pass in one orbit around the Earth, and upon recovery and data evaluation, to have been the forerunner to a manned orbital mission. The escape tower is attached to the spacecraft. In the blockhouse, the first half of the countdown went smoothly. Telemetry equipment was checked and readied. Data recorded here was used for further evaluation of the Atlas launch vehicle and were influential in further systems. The spacecraft was thoroughly inspected and no structural damage was incurred, either from the high dynamic loads of the abort or the impact, and is presently being refurbished for another flight test. In the latter part of April, spacecraft number 7 was delivered to Cape Canaveral to Hangar S. After systems checks, the spacecraft with an astronaut aboard underwent pressure testing in the high-altitude pressure chamber. The Redstone launch vehicle to be used in the flight test was delivered, checked and tested, and then raised on the launch pad. Two days before the flight, the Mercury recovery forces put to sea. And this test was to be the free world's first manned space flight. The command ship, the aircraft carrier Lake Champlain, was to be the first solid thing the astronaut would touch after a scheduled 16-minute flight into space. Gallons of liquid oxygen filled the tanks of the launch vehicle, and the launch was scheduled for the early morning of May 2, 1961. Prevailing weather conditions, however, caused the launch to be postponed. But on May 5, the astronaut selected to be the first Mercury test pilot was transported to the launch complex. Months had been spent in physical and mental tests of his readiness. A backup astronaut had undergone the same schedule. Just 2 years and 7 months after the inception of Project Mercury, under the direction of the NASA Space Task Group, astronaut Alan B. Shepard traveled the 59 feet up the gantry, and at about T-minus 80 minutes, the hatch was secured. The countdown continued. Years of training, months of trial runs, days of tests, and hours of waiting, and now the links to the Earth were receding. The launch facility's recovery forces were deployed in the event of an early abort or malfunction. At T-minus 10 minutes, the recovery helicopters left for the impact area. As countless millions watched and listened with bated breath, the astronaut maintained manual control of the craft and almost continuous voice communications with Earth. At 9:34 in the morning, the Mercury Redstone 3 flight, with astronaut Alan Shepard at the controls, traveled 300 miles, reached an altitude of 115 miles, and experienced about 5 minutes of zero G. Approximately 16 minutes after liftoff, the spacecraft, now dubbed Freedom 7, was located and recovered. The same helicopter picked up first astronaut Alan Shepard and then his Freedom 7 spacecraft. It delivered the spacecraft back to the deck of the carrier and finally landed to unload the free world's first spaceman. He received a "well done" from the President, acknowledging for free men everywhere their gratitude. Possible psychological factors resulting from the effects of weightlessness were discussed during the post-flight debriefing. After the preliminary checkup, the astronaut underwent 3 days of rigid testing and mental checks at the Grand Bahama facility. No ill effects from the flight were found. No modifications in the Mercury spacecraft were recommended by the pilot of this first space flight. All systems performed as expected in the MR3 mission. Now, additional Mercury suborbital flights were scheduled. As of this time, training for the astronauts in the stress devices is continuing. Through the continued research and development, training and practice tests, and data analysis of both launch vehicle and spacecraft recovered from space flights, major milestones in Project Mercury are expected in the near future.
What was once the furthest outpost on the old frontier of the West will be the furthest outpost on the new frontier of science and space. Houston, your city of Houston, with its manned spacecraft center, will become the heart of a large scientific and engineering community. During the next 5 years, the National Aeronautic and Space Administration expects to double the number of scientists and engineers in this area, and to direct or contract for new space efforts over $1 billion from this center in this city.
For more than 40 years, the Johnson Space Center and its people have been at the very heart of America's human spaceflight program. From the early space-era projects of Mercury, Gemini, Apollo, and Skylab, to today's Space Shuttle, International Space Station, and Constellation programs, the Johnson Space Center has been recognized as the leader of NASA's efforts in human space exploration. Between 2007 and 2025, the Johnson Space Center will continue to lead humans' presence in space through the completion of the International Space Station, the development of the Crew Exploration Vehicle, and the return to the Moon, and this time, to stay. Nearly every astronaut and cosmonaut who has orbited the Earth has noted that there are no national borders visible from space. As we move forward into the next era of space travel, those